All right, here we go. Take 3, because I keep making mistakes. Um, cotangent. The cotangent function, tangent and cotangent, were a little bit different than the sines and the cosines here. So let's just go ahead and get to it. The amplitude. We don't really care too much about an amplitude on a tangent or a cotangent because they look, like these weird wavy kind of patterns here. And the amplitude is a vertical stretch. So whether it, looks really stretched out like this, or, really compressed, maybe it looks like this, we're not too concerned with that. All right, so we kind of just ignore the amplitude on these cotangents and these tangents. But in this case, it is 1. All right, the vertical shift, though, we do care about. That is up 3. That's just the d value, so it says plus 3. So I'm going to make just a line right here, and I'm going to say that is 3 units above the x-axis. There's no scale, so we just kind of have to make our own. The next thing I want to look at is the period. The period on a tangent and a cotangent function is pi divided by the b value here. So our period is going to be pi divided by 10. Right? The phase shift, right? This is always kind of the tricky one. The phase shift, I'm going to do this down here. The phase shift is equal to negative c value. So whatever c is, make it the opposite sign. If it's positive, make it negative. If it's negative, make it positive. We're going to divide that by the b value here. So that is going to be pi over 2 divided by 10. All right, pi over 2 divided by 10 is pi over 20. All right, so our phase shift is pi over 20. To the right, it's going to the right, pi over 20 here. All right, so here's what I'm going to do. When we graph tangents and cotangents, and even sines and cosines, it's always a good idea to get 5 kind of important points here. All right, so you always start, always start with 0, and then you got to think, all right, how long is one period on this thing? Well, we know a period is pi over 10. So I'm going to put that right in the middle. I'm going to say pi over 10. And then what we're going to do is we're going to graph 2 cycles, 2 periods of this function. So I'm going to call this one 2 pi over 10. I didn't reduce it. That should be pi over 5, but we're going to leave it as 2 pi over 10 for now. The other 2 points, just chop them in half. So we have pi over 20. And then the next one is going to be 3 pi over 20, right? You can add them in your calculators, divide them by 2, kind of unreduce them if you want to think it's 0, pi over 20, 2 pi over 20, 3 pi over 20, and the last one is 4 pi over 20. All right, so when we think about these graphs with the cotangents, it starts out with an asymptote, right? And then the very next one, that's a point. All right, that's kind of where it crosses that new x-axis. So we have that vertical shift point. All right, then the next one is an asymptote. Then we cross again, and then we end with another asymptote. All right, so that's kind of what our pattern is going to look like when we graph this thing. So now what we need to do is, this is kind of like the original points before a phase shift. So here's what I'm going to do. I'm going to take every single one of these points, and I'm going to add pi over 20. All right, to each one of them. So just doing that really quickly. Let's see, pi over 20 plus 0. That's pi over 20. The next one is 2 pi over 20. The next one ends up being 3 pi. Let's see, that is, all right, 3 pi over 20. The next one is 4 pi over 20. And then the last one is 5 pi over 20. All right, so when you don't reduce your fractions, it's kind of easier to see that pattern. If we were to reduce them, it would look a little bit different. All right, but these points, all right, these ones that I have in purple here, that kind of represents the phase shift. So I'm going to take these points and let's put them up here somewhere. All right, so these are kind of the order pairs that we're going to have. All right, so let's just find a good spot for them on the graph. 5 pi over 20, that's all the way at the end. And then the other ones are going to be somewhere kind of in the middle. My thing is not cooperating here. One moment, please. All right. So we have, well, guys, it's always something here. Take this one and drag it over. And then I want to take this one and drag it over. All right, there we go. Those are the new spots here. So according to, so these are on the x-axis over here. All right. Now, according to the pattern that I have drawn here, you want to start with an asymptote. So we are going to draw an asymptote right here. And then this is where it crosses kind of that new axis. And then we have another asymptote. And then we cross the axis again. And then we have a third asymptote right here. All right, so now let's just go ahead and graph this thing. It is a cotangent. Cotangent starts at the top and kind of goes down. So it looks something like this. That is our cotangent function. Now, the range on these things is negative infinity to positive infinity. All right. The domain, though, the domain is everything that is not an asymptote. So what I'm going to do is I'm going to say, hey, x cannot be equal to. We have to think, all right, what is x not allowed to be? And if you look where those asymptotes are, I see a pi over 20, 3 pi over 20, 5 pi over 20. There's kind of a pattern there to describe what's going on. So if you look here, it's the odd numbered pi over 20s. So I'm just going to say odd multiples of pi over 20. All right, so if you think like 2 pi over 20, that's an even number. That's fine. We have a point there. It's just the vertical asymptotes that are not allowed to be in our domain there. All right, and there's our cotangent. The next one, cosine. I think these are a little bit easier. Let's take a look here. The amplitude is 5. All right, you notice that there's a -5. That minus sign here just tells us it's going to be flipped upside down. So I'm going to write a flip here, just so I don't forget. That was supposed to be an arrow. The vertical shift, if you want to think about it, that's always going to be plus that last number. There is no number here, so the vertical shift is 0, or you could just say none. So what does that tell us? That tells us our midline does not move. That is just going to be, right where it normally is. The amplitude is 5, so that means our maximum and our minimum are going to be 5 units away from the x-axis here. All right, so you're going 5 up, you're going 5 down. The phase shift. Actually, we're going to do the period first. The period is 2 pi. 2 pi over 1/4. It's a cosine. The period on a cosine is 2 pi. So it's 2 pi divided by the b, which gives us 8 pi. All right, that's the length of one cycle, one period. The phase shift, again, I'll do that over here. The phase shift is going to be negative pi over 1/4, which gives us 4 pi. All right, so your phase shift, we're going to the right, 4 pi. All right. Before we even graph it, we could do the domain and range, actually. We know the domain is all real numbers, so I'm going to say negative infinity to a positive infinity. And then the range, the lowest it gets is -5, and the highest it gets is +5. And I'll put those in brackets. Now we can actually graph it. Just how we did with the cotangent in the last problem, I'm going to do again here. I'm just going to graph one period though. Right, so normally it starts at 0 and it's got a period of 8 pi. So I'm going to have this endpoint be at 8 pi. All right. So let's see, right in the middle, that's going to give us a 4 pi. And then chop that in half again. We have a 2 pi. And then we have a 6 pi. All right, so those are kind of the 5 key points here. All right. So with that phase shift, all right, we're going to add 4 pi. So add 4 pi to everything, right? Nothing too groundbreaking here. 4 pi, 6 pi, 8 pi, 10 pi, and 12 pi. Right? Those are the kind of important points. So here's what I'm doing. I'm just going to graph those. I don't have much room, so if I say this is 4 pi and this is 12 pi, just kind of make it up as we go. So the middle one is going to be an 8 pi. And then we have a 6 pi right here. And then we have a 10 pi. And all right. The last thing to keep in mind is what's the shape of this one? It's a cosine. We know a cosine graph starts up top, dips under, and then ends up top. However, it's being flipped upside down. So we have to account for that. So instead of starting at the top, it starts at the bottom. And then the very next one passes through the midline. It, hits the top and then comes back down. And it's going to end on the bottom. So our cosine graph, if we were to plot this thing, is going to look something like that. All right, that is graphing one period of cosine. All right, I think that's good. I don't think I made any mistakes this time. So this video is done. This was page 2. So hopefully we'll see you guys on page 3 here soon.